Good afternoon. This is Mrs. Lynch here. I am about to talk about 45, 90-degree triangles and the special relationship that their sides have with each other. I'm going to fix my screen here in just a second so that hopefully you can see the full screen there. Okay. So what I have showing on the screen right here is actually part of the star geometry chart. And the reason that I have this is I wanted to show you that there's something very helpful that they put on this geometry chart that will help us with our relationships of the sides of 45, 90-degree triangles. And this is basically what I use to help teach it. Now, you can see that we have our triangle here. There is the 90-degree angle, our box in the corner, all right? And the other two angles in the triangle are 45-degree angles. They are the exact same size, all right? Now, if you were to look directly across from both of those 45-degree angles, you see that the length of the side there, they're labeling as X. Now, X is just a placeholder to represent a number. So most of the time when we work these problems, they are either already going to give us that number, or we are going to have to find it ourselves. Now, if you look across from the 90-degree angle, we have a different amount, X square root 2. Okay, all of you who have taken algebra before are used to seeing things written like such as this, where you have a number attached to an X. Now, we all know that that means that those things are being multiplied together. This actually stands for 5 times X. All right, this X root 2 is no different. They don't put the sign in between, all right, because it's unnecessary. All right, but what this X root 2 actually means is X times the square root of 2. All right, so you will see it written like this and not with a dot or your typical multiplication sign in between them. Okay, all right, so now let's actually look at a problem, why we would want to use this and what we're going to solve for. All right, I drew up a couple of examples here. All right, this is one example of a 45, 90 triangle. All right, you can see my 90-degree angle box in the corner, but I didn't label the 45-degree angles on here. I didn't really need to. I still know that they are 45 degrees, and this is why I know that. All right, these two 5 sides that have a length of 5 are the same. All right, what that tells me is that the angles that are located directly across from them, which would be my bottom angle here and my one on the right here, those angles have to be the same as well. All right, because of the fact that all 3 angles add up to 180 degrees in a triangle, I can figure out basically that those 2 angles must both be 45 degrees. All right, so even though they're not written in, sometimes you have a 45, 90-degree triangle and you don't even realize it at first. All right, so here's the best way, I think, to solve this type of problem. I am going to match up my picture here with the formula that's on my formula chart, all right? If you notice, all right, just like before, the 2 sides that were located across from the 45-degree, they labeled X. I'm going to do the same thing on my picture over here. All right, this was a 45-degree angle, and so I'm going to label it X. All right, this one was also a 45-degree angle, and I'm going to label it X as well. All right, basically what that means when you have a number and a letter both on that side, or we've labeled that side the exact same thing, it means that they're equal. right? In this case, our x is equal to 5. We're going to use that to actually find the third side of our triangle, all right? On our formula, okay, the formula for that side across from 90 is that we are to take x and multiply it by the square root of 2. All right, well, we already know what our x equals. X equals 5. This is just a simple substitution. If x equals 5, I plug in 5 right there, and I'm going to multiply it with the square root of 2. All right, this right here would actually be my answer. Okay, I don't have to actually multiply those together. One is a number and one's inside a radical. You can't do that. You could type in 5 times the square root of 2 into your calculator, but then you get some pretty long decimals, which I think is a little bit uglier than just writing our answer like this. So I'm going to go ahead and leave that one alone. It's pretty simple as long as you match it up with your picture in the formula. So let's try another example. This one's going to be a little bit different. All right, I have another 45, 45, 90-degree triangle. This time, it's the side of the triangle that's across from the 90-degree side that's given to us. We do not know what the two sides located across from the 45s are going to be, but we're about to figure them out. Once again, I'm going to use my formula, right, for a 45, 45, 90 triangle on my formula chart. So let me bend this back real quick and so we can see it a little bit better. Okay, and compare them. All right, so I'm going to label my triangle on the orange paper just like they did on the blue, okay? Across from the 90 is the side that's supposed to be labeled x square root 2. All right, well, we talked about this earlier, that if you label one side 2 different things, what that means is that they actually are equal to each other. All right, so currently we know that 7 times the square root of 2 is equal to x times the square root of 2. All right, across from my 45-degree angles, I should label both of those x. That makes a lot of sense because those are the sides that we are looking for. And a lot of the time when we don't know the length of something, we call it a variable like x so that we can then find it. All right, well, we actually have set up for us already a very easy algebra equation to solve. All right, I want to know what x is all by itself. Right here I have equation written out where x times the square root of 2 is equal to this. If I want to isolate the x or get it by itself so that I know that just what it is equal to, what I need to get rid of is this times the square root of 2 part. How I'm going to do that is to divide. Opposite operations undo each other. All right, whatever you do on one side of an equal sign, you must do to the other. All right, and here we have a very cool situation which makes things really easy. When you have the same thing written on the top and the bottom of a fraction, they equal 1, which cancel each other out. So this square root of 2 divided by the square root of 2 cancel out, and they also cancel each other out on the left side of the equal sign. Therefore, all we're left with is x is equal to 7. Now, I bet you could have figured that one out without actually having to do that. I think it was pretty obvious. However, when we get into some harder problems, it's really helpful to always set them up that way. And that's why I went ahead and did that for this one. Okay, now we have found our 2 missing sides, and they should always be the same number. All right, let's look at one last example. And this one is also a little bit harder. Now, this one is also a 45, 45, 90-degree triangle. Okay, the two angles that are unlabeled, located across from the sides that are marked congruent, are the 45-degree angles. Again, I'm going to match those up with the triangle on the formula chart. So across from the 45-degree angles, I would write my X. And on the side across from the 90-degree angle, I would write my X square root 2. Again, if we label a side the exact same thing, then that means that they must be equal. So that's why I'm going to put my equal sign in between the 8 and the X times the square root of 2. All right, here I have another equation set up that's going to help me solve. We're going to do this the same way we did in the last problem. I can try to get X by itself by basically undoing or getting rid of the multiplied times the square root of 2 part. So I do that by dividing by the square root of 2 on the right and by the square root of 2 on the left. On the right side, it works out nicely because the square roots of 2 cancel each other out, and all we're left with is X. Now we just have to learn how to simplify this on the right, but that's for another video. All right, so in this case, I got that X is equal to 8 divided by the square root of 2. That must be the length of these two sides located across from the 45-degree angles. All right, so if you need to learn how to rationalize with a square root in the denominator, I'm going to make a little tutorial video for that. Also, I'm about to do a video for 30-degree, 60-degree, 90-degree triangles to help you out with that. Have a great day.